All right, so head up series and sequences, right? All right, so let's go with the most popular. You can mute it. On the video. Hold on. Let's see, no? Somebody have a link for there. I know this Wi-Fi here, right? All right, so yes, so we're looking at, right? We're looking at series and sequence. Anybody? It's yours? Yeah, that's this gonna go. See that will help. Are you ready? So the first thing we're going to learn is about what's the difference between a series and a sequence, right? Anybody knows the difference between a series and a sequence? What's the difference between a series and a sequence? You're here okay online, right? Online? Well, here okay? All right, nice. Right, so what's the difference between a series and a sequence? So let's start with a nice simple example for a sequence and a simple example for a series. Right? So a sequence looks like this. 1, 2, 3. That's a simple sequence. Right? Right? So you have a nice ordered series, sequence here where all the values what? All the values increasing by 1. What's a series now? A series is simply adding up all the terms in a sequence. That's it. A sequence, no number sign. A series, number sign. That's okay? Now, this here could go on, right? What we could do, right? What we could do is we could use our formal notation to help simplify this, right? So notation to simplify a series, right? We're going to use something called the summation. All right. So before we focus on sequence and series, we're going to focus on summation. Right? So I want to show you how to write this using this symbol here. Right? And it's written like this. Right? I'll explain this again just now. But I could write it like this. All the values from 1 to n. So R, and let's call it R. R starting at 1 and it finishing at n. This and this mean the same thing. Right? So I'm going to explain this here now. Right? Just copy down this small example. I wanted this to head up summation. Right? We are going to focus on summation. Right? So once you see the symbol, I want you to be able to work with it, right? Right, I'll give you a formal definition on sequence and series later on. We're just going to focus on summation. Ready? I set up summation, right? All right, so if we have all right, so if we have something like this, if we have this symbol summation, right? R equal to 1 to 5 of 2R, right? In words, right? In words, this symbol means the summation of 2R as R goes from 1 to 5, right? So it basically means that we want to sum up all the terms that represent 2R, where R goes from 1 to 5, all the integers. So it looks like this. 2, starting with R is 1, plus, after 1 will be 2 until it reach 5, right? So you're summing up all the 2R terms where R goes from 1 to 5. Are you okay with that? Yeah. So you're summing up all the 2R terms where R goes from 1 to 5. So R is 1, then 2, then 3, then 4, then 5. Right? Plus 2 by 3, plus 2 by 4, plus 2 by 5. Are you okay with that? And well, we can work it out. This is 2 plus 4 plus 6 plus 8 plus 10. So that's 10, 20, 30. So it means that the summation of R going from 1 to 5 of 2R to 30. Okay with that? Right? Yeah. So in words, right? In words, it means the sum of the term, sum of the term 2R as R goes from 1 to 5, right? And now let's list out integers 1, 2, 3, 4, 5. Okay with that? So that's basically what this summation means. Of course, if it gets too big, then this will be too hard to work out, right? And I will show you how you'll handle that later on. Online, are you okay with that there, Faraj? Right? You'll understand the summation, right? Yeah. So you have the summation of 2R as R goes from 1 to 5. Right? All we're doing is we're simply replacing R with all the integers from here to here. That's okay? Right, somebody was new online here. Everybody okay, right? Richard, you okay with us? Rian, you okay? That's you? Yeah. And there were 2 new monster girls. That's your own class, but from 4 maths probably. All right, that was somebody. Are you okay with us? All right. So, when you clear the board, right? Summation of 2R as R goes from 1 to 5. Right? You don't really have to write this, but it's important that you understand what this means, right? All right, so I'll give you an example then. Right? See if you can find it somewhere. See if you can find the summation of R going from 1, I wouldn't go too far, 2R, right? Of R, sorry, 2 2r squared. Only the r is squared. 2 by r squared. Right? Find the summation of r going from 1 to 4. Find the summation of r going from 1 to 4 of 2r squared. Take your time. We're supposed to do a Kahoot today, but wait, no, for a login. Or it's showing me on one device. I don't know. I changed this whole thing. Right, ready? No. Right here, nice message answer online. Nice Keelan, nice Sahara. Ariana, nice, good. Aliandra, good. Yes, yes. All right, so let's see. So it's 2 by r squared, so that's 2 by 1 squared plus 2 by 2 squared plus 2 by 3 squared plus 2 by 4 squared. So that'll be 1 squared is 1 by 2 is 2. 2 squared is 4 by 2 is 8. 3 squared is 9 by 2 is 18. 4 squared is 16 by 2 is 30. Add it up, that's 46. Nice. Here's what you can also do, right? You'll recognize that you have 2 in front of all of them. So what does that mean? You can factor it out. Yeah. So what you say? So if you have the summation of r going from 1 to 4 of 2r squared, if you want, you can take it 2 and bring it in front. So it's 2 by the summation of r going from 1 to 4 of r squared. So you can take it 2 and factor it outside. Okay. Try this here. Summation of r going from 1 to 3 of 2r plus 1. Of 2r plus 1. Next. Guys, so your first term is what? Your first term is 2 by 1 plus 1. Second term is 2 by
2 plus 1
all right. Then 2 by
plus 1.
so this is 2 and 1 is 3. This is 4 and 1, 5, 6 and 1, 7. So that's 50. Right? Yeah. Try number 4. I want you to sum R going from 1 to 6 of 4. Just 4. Just 4. Give an example. Yeah, 3 now. For shots. Thanks to her. R going from 1 to 6. What is that? Give me a minute again. Much shall I get? Any answers? I seen some zeros. Jacob, where you got? Don't make sense. So guess what? Nothing at all. So say better part answer. What do you put? Nothing. All right. So let's see. So when R is 1, what will the value be? When R is 1, the value is what? Which, okay, so let's say it in words, right? We sum in 4 as R goes from 1 to 6. So the first term, R is 1. Is there any R here? So this will have to stay as 4. And we sum in 4 as R goes from 1 to 6. Yeah? So when R is 1, it's still 4. What about when R is 2? Still 4. What about when R is 3? That's okay? So there is no R here to change the value. So this is considered a constant. Right? So it will be 4, 4, 4, 4, 4, 4, which is 24. So from that, I want to give you 2 little rules. From that, I want to give you a few rules here. Right? Rule number one. If you sum in R going from 1 to n of k by any function, according to the function AR, we can take the k and pull out the k. Right? Remember, I showed you this, right? You can take the k and pull it outside. I'm going to show you an example. You can factor it 2. Same thing here, right? Suppose now you have to sum R going from 1 to n of some constant, just like our example here. And it doesn't help. What do you all think I should write here? K by n, just like here. 4 by 6, right? 4 by 6 is 24. So here is just n by k. Right? It has some more rules, but you don't always use them. I'll still give them here. R going from 1 to n of a to the r plus or minus b to the r. So if I give you two separate functions, you can work them out separately. Right? You don't really use this rule so much. I wanted to show you these rules here, right? All right, so nice. That's our intro into summation. Right? So these are the two main rules that that you would really use, and I'll show you in a few examples, right? All right, let's go back to sequences. All right, kind of sequences. Kind of sequence. Right, head up sequences. Ready? A sequence. A sequence. The collection of elements. A sequence is a collection of elements that follow a particular pattern, based on a mathematical formula. Based on a mathematical formula. Based on a mathematical formula. So repeat, please. All right. A sequence is a collection of elements that follow a particular pattern based on a mathematical formula. Based on a mathematical formula. Right. Remember, if things bad and you all didn't hear, you could always go back to the YouTube video that live and hear it, right? It'll be delayed by about 20 seconds or more. Right? So what I just say there in the future, if we go back in YouTube, you'll hear it 20 seconds later. All right, so nice. First up, there are two popular sequences that we'll focus on. There are two popular sequences. There are two popular sequences that we'll focus on. Number one, an arithmetic. Number one, an arithmetic progression called an AP. An arithmetic progression called an AP. And two, a geometric progression called a GP. Number one, an arithmetic progression or AP. Number two, a geometric progression or GP. Ready? All right, so ready? So head up APs and GPs. I'm going to give you a table and show you both of them at the same time. Right? I'm going to show you both an AP and GP at the same time, right? Of course, you'll have to figure out which is which. Calculators needed, not as here. Might be needed today. Shannon, you should have one next year. So you might need it. Ready? Good. So we're gonna see what an AP looks like, right? And I'll show you a very simple AP. And the simplest AP is 1, 2, 3, 4, 5, right? What's important here is E. A is called the first term. Right? And the first term in our example here is what? 1, right? Are you okay with that? The first term in our example is, A is equal to 1. That's the first term, right? And what's the pattern here, Olivia? You're saying that they all increase by 1, right? That is called D, common difference. Common difference, right? I write a little small there one line. That word there, common difference, right? And our example is 1. Right? So in our example, common difference is 1. All right. So generally, here's how we could write a AP. An AP can be written like this, right? The first term is A. The second term, you're going to add D to it. Third term, you're going to add D to the second term. And fourth term, you're going to add a next D to the third term. So on and so on. Are you okay with that? See what I did there? The first term is A, and to get the second term, I'm adding D to it. So if you look at our example here, 1 plus 1 is 2. 1 plus 2 by 1 is 3. 1 plus 3 by 1 is 4, and so on and so on. Are you okay with that? Yeah? Okay with this? Yeah, see it drift away there. Right, so every AP looks like this. Still thinking about procedure. Right? Are you okay with that? Online? Are you okay with what's an AP? Ocean? Right, so an AP basically looks like this. They all have a common difference. It can be positive, it can be negative, it can be a fraction, it don't matter. Right? Each one of them, they vary or they change by that common difference. Are you okay with that? Online? Are you okay with that, Maria? So we're doing the same topic Saturday, no end, and Saturday tricks, no shovel. So champ, pay attention. Right, Maria, are you okay? Right. So this is the AP. Everybody okay with that? Now GP now. Looks a little bit different, right? Let's say we start our first term with 2. Then a GP, the next value may be 4, then 8, then 16, then 32, and so on. Well, what you recognize about the GP? To go to the next term, you have to keep multiplying by a value, right? So to go from here to here, multiplying, here, adding, right? So here you multiply by 2, here you multiply by 2, multiply by 2, multiply by 2, right? So for GP, yes, we have a first term. Yes, you have a first term, which is 2, but instead of a common difference, you have a common ratio. Right? Common ratio, and common ratio in our example is 2. By the way, this is just coincidence, with two of them being the same. Right? All right, so generally, how would I write a GP? Let me pick on somebody right here. Kilon. How would I write a GP? Let me write a EPF here. What's the first term? E, right? I'm picking on Kilon. Huh? Yeah, you want to try? I see the first, I'll let you try. Actually, help me out there so you want something, huh? Yeah. A, then, and AR, 1 AR squared, right? And then, right? She help you out there. All okay with that? So basically, AP looks like this and GP looks like this. Good job, Chevelle. Everybody okay with that? Right. Hey, Mr. Sean, you need to get a sample there. All right, good. So we know what's an AP and GP, and we have the little principles behind it. To my paper, you'll tell me what each one of the things is here, right? Right, so I would like you to determine if it's an AP or GP, and then put in the missing term, right? Come on, in missing term, if it's an AP or GP. So you have 3 examples on the board. I want to know if it's an AP or GP and the term not missing. My marker is dead. So I wonder if it's an AP or GP and what's the value that missing, right? Check all it, don't get too excited by the first 3 terms. Huh? You have to check the 4th term and make sure it's behaving like that. It's very behaving like I do. Right, hurry up. Let's see what you got. Oh boy, the speed of putting number that was simple. You find out on this day, I think I'm 7 years. No, I won't carry to him. What? I will carry to him. You do your phone? No, I'm not. Passam home my order. Home my order. No other way here. Here, drop it home from any time of the day. Hope you remember. Ready? See on one of these. Right, Jacob. First one. Huh? The strength is 13. Is that AP? First term is? First term is what? First term is 2. So the first term you see in here. First term is 5 and common difference is 2 plus 2, right? Nice. Next one. Prestige one. I don't know what you think about, sir. Yeah. All right, GP and the value missing here is 4. Still daydreaming, right? A is 4 and R is a half. Right? Last one, Ishana. Last one is a huh? You know?
AP.
The AP.
A is 4.
A is 4.
B is -5.
A is -5.
A is -6.
-6. Is yeah. Is some of 3 and 4 patterns. No, AP is common difference, not totally. It can be positive or negative. Okay, so put it like this, right? Add -5. You get it, right? But as I told you before, R could be positive or negative. Sorry, T could be positive or negative. Huh? Positive or negative, adding the value. Right? Right? So in an example like this, here we is to write. In an example like this, to figure out if AP or GP is two things you have to check. You take this value, and minus this value. Take this value and minus this value. Take this value minus this value. And then check and see if they equal. If they equal, you have an AP. Right? If they're not equal, then you have to go and check the division now. Check -1 on 4. Then check -6 on -1. Check and see if they equal. If they equal, then you have a GP. Right? So sometimes it can be more challenging. Right? And you have to use a technique, and I'm going to give you a formula for it now. Right? So what you see, I do have a different coloring. But there are 2 things I want you to note here. But okay online, put number 3. Shannon, well, okay with number 3? Yeah. All right, Samira, yeah, nice. Right. So how do we get D now? So note that there are 2 things I want to note. D, right? I shall label this here for you. Sorry, I shall label this here. This here is your first term. This here is your second term. This here is your third term. This here is your fourth term. So to get D, you're minusing any 2 consecutive terms. So you can subtract 2 and 1. You can subtract 4 and 3. It's up to you. Right here, this is your first term. This is your second term. This is your third term. This is your fourth term. So to get R, you divide it. You can divide your second term and your first term. You can divide your third term and your second term, and so on and so on. right? So if these values are the same, you can't do one alone, you have to do more than one. If these values are the same, then you have R. If these values are the same, then you have T. Okay? Right? And you have one last formula to learn. Copy it down. You have one last formula to learn here. Don't be saying like you know why you find out. Right? One last formula. You don't want to have to keep writing this out and trying to figure them out, right? That there must be a way for you to find any terms, right? And the general term called T to the N. Anybody seen a pattern? Anybody seen a pattern here? Suppose I wanted the fifth term. The fifth term is what? A plus. Suppose I wanted the ninth term. What would it be? A plus 8D. Suppose I wanted the 20th term. Right. So your formula for the nth term is what? A plus
N minus 1.
n minus 1 b. Right? And the general term here. And the general term here is what? AR to the n minus 1. So you have two formulas here to learn now. So instead of having to write out all of this, we could just learn this formula here. Right? Notice we did an AP and GP side by side, right? So you have to be able to watch them and figure them out. Oh, we take long correct. You move both. Not watching time then. All right. As a quick practice, here's what you're doing. Come on. I want you to go back to the original examples 1 and 2. Right? So we have 1, 2, 3, 4, 5. I'm gonna give you a number that when we write out, right? 20th term. See if we can find the 20th term using this formula here. Right? Same thing, no. 1, 2, 3, 4, 5, let's find 10th term. Actually, that'll be kind of smaller. Find 8th term. Right? Here's what we're doing, right? Here's what we're doing. We're going to use this formula here to find the 20th term. So n is 20. A is how much?
5.
A is 5. And D is 2. And then I want to do the same thing here when n is 8. Try that fast. Alejandro, you okay there? Michael, are you okay there, right? Right, so all you just plug in A, N, and D. Plug in A, R, and N. Same examples I gave you all earlier, right? Find the 20th term and the 8th term. Rather solve this no homework problem. We solve it. We call it start now or we'll finish it. 1 question, 5 minutes. How do I solve it? And give Wilson's Cubans about his homework. Huh? Against to know who So is this correct to? I do not know. I will check just now. Looking correct to. Oh, good, Malini, someone wrong there. That will be. We got it real nice. Right, keep messaging the answers. Rian got, we're looking correct, Rian. Shannon got T20 is 25. Yeah. So we're using A is 5 plus n minus 1. So that's 20 minus 1 by D. D is 2. So that's 5 by 19 by 2. That's 38 plus 5 is 43. Yeah. Each term is 4. R is half to the power of 8 minus 1, which is 7. So that's 4 by a half to the power of 7 is what? To the power of 7 is someone. Anyway, 2 to the 7 and 2 to the 2, so that's 2 to the 5. So that's 1 over 32.
Yeah.
Right? 1 over 32. Yeah, n minus 1. That's looking like n minus nd. What? That's n minus 1, Shannon. Oh, looking like an n. Oh, okay. Let's up there a little bit. All they do make sense, but all right. Well, this thing's trying to give trouble here. You all seen that problem with this screen online?
Yeah.
What I was saying now?
Yeah.
I wonder what is up, boy.